directly to the phospholipids in creating pores, and some that cause target cells to undergo apoptosis, which is a programmed cell death. B cells, like T cells, also have a receptor on their surface that allows them to only bind to an antigen that has a very specific shape. The main difference is that B cells do not need antigens to be presented to them on an MHC molecule. They can simply bind to an antigen directly. When a B cell binds to an antigen that's on the surface of a pathogen, it's capable of phagocytosis and antigen presentation. So technically, they're also antigen-presenting cells as well. Like other antigen-presenting cells, the B cell loads the antigen onto an MHC molecule called MHC2 and displays it to T cells. When a T cell gets activated, it helps the B cell mature into a plasma cell. And a plasma cell can secrete lots and lots of antibodies. Typically, it takes a few weeks for antibody levels to peak. The antibodies, or immunoglobulins, have the exact same antigen specificity as the B cell they come from. Antibodies are just the B cell receptor in a secreted form, so they can circulate in the serum, which is the non-cellular part of attaching to pathogens and tagging them for destruction. Because antibodies aren't bound to cells and float freely in the blood, this is considered humoral immunity, a throwback to the term humors, which refers to body fluids. Now, the final type of lymphoid cell is the T cell, and it's in charge of cell-mediated immunity. T cells are antigen-specific, but they cannot secrete their antigen receptor. A naive T cell can be activated or primed to allow it to turn into a mature T cell by any of the antigen-presenting cells, but most often it's done by a dendritic cell. Now, there are two main types of T cells, CD4 T cells and CD8 T cells.